So looking at this, we can get here will be class mark. So the first one is our class mark. Oh. Class marks. We can also consider here too. We can consider maybe our class boundaries here. Class boundaries. Ruben, talk to me. You can consider class boundaries. Class boundaries here. Then we can consider the last part to be maybe the frequency. Yeah, maybe you can consider the, what do you call it? Frequency here. So that's it. So maybe the class marks, we were given the class marks to be. Let us. So here is 30. So you can get 30 to 35. You can get our next one to be 35 to 39 or 40. You can say to 40. To 40. Then we can get. Come on. So you can get 42, maybe 44, and so on and so forth. So if you are to find for the class boundaries here, just as I said, you always find this is the lower class boundary and this one is the upper class boundary using this way. But here, if you are using the class intervals, this one is the upper class limit and this one is the lower class limit. But using the boundaries, here becomes the lower class boundary and here becomes the upper class boundary. So we subtract, we find the difference between this and this. When we find the difference, we are going to get 1. Then we divide it by 1. We divide by 2. Now when we divide by 2, we multiply it by half. So when we multiply it by half, then when we multiply by half, then what we get, we add it to this, then we subtract it from this. So looking at this one will become 29. This one will become 29.5. I'm going to get 29.5 here. 29.52. This one will be 34.5. 1.5. Then we can talk about the next. We do same for the next one. So the next one, the difference between this is 1. So then that means that we divide by 2. We are going to get 0.5. So we add 0.5 to this. Then we subtract it from this. So we are going to get here will be 34.5. 2. This one will be 39.5. So that's what we are going to do. So this one becomes our class boundaries. This one becomes our class boundaries. And when we ask the class advanced, I will show you where we use it and so on and so forth. So it's not always you are going to get 0.54. Now let me give you another example. Let's use this example and see. I will let you give me this thing. Okay. So we have something like this. So let's say we have so what will be the class boundary here? Who can tell me? What will be the class boundary here? Who can tell me? Talk to me. Harriet, what will be the class boundary here? I'm listening. Harriet, talk to me. Ruben, talk to me.
Sir, please, I had 940 to 1040.
So this one be 9. You said 9 what? 940. Okay. 942. 942.
1040.
1040. Good. And the next one will be. So the next one will become 1040 to what? 1140. And so on and so forth. So that is it. So you just have to understand
Yes,
how the formula works and so on and so forth. That's what we call the class boundaries. So we've been able to understand class boundaries, class limits, class intervals, and so on and so forth. So that is it. Now we are going to talk about the class size. The class size. The class size. Now when we say class size, then we are saying that class size is normally the difference between the lower and the upper class of a class interval. Lower and upper class of the class interval. So for instance, if I have this, my class boundary will be I'm coming out. My class boundary will be the difference between the class boundaries. So now after being able to find these boundaries, after finding this becomes my class boundary. So now this one now becomes my upper class boundary, then this one becomes my lower class boundary, because we've been able to find for the class boundaries here. We've been able to find for the class boundaries here. And so this one becomes my lower class boundary, this one becomes my upper class boundary. Now the class size is the difference between this and this. And so the difference here is 40. I don't know if you're getting it. So the class size for this one is 40. Or the class size for all will be 40. For the class boundaries is 40. I hope I'm right. So normally the class size is normally the difference between the lower class boundary and the upper class boundary, using the boundaries, the class boundaries. And so if you are asked to find for the class size, given this class marks, you first have to find for your class, what do you call it, your class boundaries. And after finding for your class boundaries, the difference between them, your class boundaries becomes your class size or width or anything you want to call it. Are we there? So that is, so the upper class boundary minus the lower class boundary. And so now that is it. That is it. So our class boundary is, you realize that when we use this, it's going to be different. When you use this, it's 20. And this is what we are going to use. So normally the class width or the class boundary, we use the class boundaries, the class size, sorry. We use the class boundaries in calculation. We don't use the normal class marks. We use the class boundaries for the calculations. I hope I've made myself clear. Have I? Hello, have I?
yes,
Yes, so the difference between this will give us the lower class boundary and the upper class boundary will give us this thing. This one's the upper class limit and the lower class limit. We don't use this class, we don't use the class mark, we use the class boundaries to find for the class width and the size or something. They're the same thing. Now here I'm going to talk about class midpoint or mid value. 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 So with a class midpoint or mid value, it's normally it's first half times into bracket the lower class limit plus the upper class limit. So with this one, looking for the class boundary, looking for the midpoint or the mid value, you add this two, then you divide by 2. You add a class mark. So we are the what you realize that the formula I give you is half into bracket lower class limit plus the upper class limit. So anywhere we use the limits, class limits, class this and lower class this and limits, we are talking about the class mass. Anywhere we use the class boundaries, we are talking about this. So the upper class boundary is this, the lower class boundary will be this. So that is it. So looking at this, our mid value will be 980 plus 1000 divided by 2. That will give us our mid value. So for instance, if you are giving 5 to 9, Our made value will be 5 plus 9 divided by 2. 5 plus 9 is what? What's 5 plus 9? 5 plus 9 is 14. So 14 divided by 2 is 7. So our made value becomes 7. Or our made point will become 7. I hope I've made myself clear. I hope I've made myself clear.
Yes, sir.
So let me check the time. Oh, let's see if we can. So maybe they've given us work. So the table below gives the number of children born on different days in a month in a dental maternity home. Prepare an ungrouped frequency distribution table for the data. For the purpose of the class and the two we are using, we may not be distant, but we are given two. We are given, I'll just write a few. We are given two again, we are given 4, we are given 3, we are given 2, we are given maybe 4 again, we are given 0. There's plenty, but I'll use the first point, the first stuff. We are given 5, and we're given 1. Then we've been asked to, there are plenty, but I just want to use the first one. Then we've been asked to prepare an ungrouped frequency distribution table for the data. An ungrouped. So with the ungrouped, yeah, you're talking about the individual characters. And so then you first draw a table, distribution table. So we first draw a distribution table. And so we can have something like this. Then we have our class mark here. So here will become our class mark. So this one will become a class mark. Class mark. The CM, let me use CM. That will be very short. Class mark. Then this one will become frequency. Frequency. Then what do we have? We have 0 here. So the first mark will be 0. We have 1 there. So 1 will be this thing. That means those who had 0, those who had 1. Then maybe we have 2 here. We have 3 here. We have 4 here. And we have 5. Now we are coming to the occurrences or the frequency, in other words. So how many people had 0? Rashid, how many people had 0? Rashid, how many people had 0? So looking at this, only one person had 0. So our frequency here is 1. Then how many people had 1? That one is 1. How many people had 2? We had 3. How many people had 4? How many people had 3? 3 is 1. How many people had 4? 3.
3.
How many people had 5? I think 1. So this one is a typical example of what do you call it? A typical example of an ungrouped frequency. So this one is this and this. We are not talking about the individual, the interval, class interval, and so on and so forth. We are talking about the individual distance max. So the people who had 0 is 1. You get it. So that is it. If we were to do the group form, we could have done it this way. Okay, maybe normally the group form normally entails a lot of large class size. Normally entails a large class size, and so we could have maybe we are talking about percentages here or something. Maybe here is 10, 10, 10, 20, and those things. And now we consider, okay, normally with a group, the question can say, for instance, the following numbers are heights in cm of a group of 56 students. Now we have 139, 140, 165, 155, 145, 148, 156, 160, 157, 143, plenty. Then they say prepare a group frequency table by taking the class intervals 135 to 140, 140 to 145, and so on and so forth. So now they've given the class interval and they've given you the starting point. Let's say the starting point is start from 135 to 140. And so having given you the distance, then that means your first class size will be 135 to 140. 140. Then you can also talk about, and he said the second one is 142. $145. So we have something like this. Then maybe we are giving the values 139, 140, 165, plenty. So the question says that we should put it in a group distance, and it has given us the first starting point 135 to 140. It also gives us the second one 140 to 145. And so just looking at this, you realize that the interval is 5. Yes, it's 5. So that means here we start from 1, you continue. So if there's 135 to this thing, and the other one is 140 to 145, then we can also consider 145 to we can also consider 145 to, what do you say, 145 to maybe 150, and so on and so forth. So from there, then we come and group it. Okay, how many people had from 145 between 135 to 140? Then we can talk about that. How many people had between 140 to 145? Then we group them, we count them, then we can write their frequency. How many people had 145 between 145 to 150? We can also consider that. Then we are good to go. So after getting our frequencies, then they say what is the class width. So with the class width, that will, because there's a class width, then that means we would have to come and find for the class boundary. So the class boundary would have to do is, okay, this one, the class boundary of this will become 134.5 minus 8 to 140.5. That is how it's going to be. Then we do our class boundary. Then from there, we can be able to get our class size or something. We can be able to get our class size. We can be able to get our class. Just as how I material know how to get a class size. We can be able to get our class size. So that is it. Now let's talk about the graphical representation of data. 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 Now, so yeah, we can now consider graphical representation of data. So now our data, we can graphically represent it. So you realize that for the COVID-19 data they've been given on this thing, on the TV we've been watching, you realize that there are sometimes they represent it graphically. You get it, like some curves and so on and so forth. These are graphical representations of it. And any data analyst should be able to tell, okay, from here to here, this is what it means, and so on and so forth. And so after being able to draw or get your data set represented in a table form, then now you can represent it in a graph form, so that anyone can just pick in a graph should be able to tell that, okay, realize that now, for instance, if they want to consider people who have gotten maybe, or the hike in, what do you call it, the hike in the cases recorded maybe yesterday and today, and then maybe they are drawing within a period of 5 days. Looking at the graph, they can say, okay, today maybe 50 people were recorded, but tomorrow maybe 70 people are recorded. And now they can say, okay, then the difference between from today and what is recorded, or what was recorded yesterday is maybe 20. Looking at the graph, it should be able to tell you all these things. Or maybe looking at the graph, you should be able to tell that, for instance, if they are drawing the graph to represent the African countries who have been able to, who are privileged to get this virus, or who are unprivileged to get this virus, then they can tell that, okay, looking at the graph, we realize that the graph, looking at the graph, I think Egypt is the highest, or maybe South Africa is the highest, and maybe Egypt. Looking at the graph, they should be able to tell all these things, the number of deaths. They can all get all these informations and just represent it in a graph form without even you having to look through the details and so on and so forth. So that is it. Now, under this study, we are going to consider, we have four main types of graphs we're going to consider. We're going to consider the pie chart, we're going to consider the bar chart, bar chart. We are going to consider the histogram, and we're also going to consider the cumulative frequency curve, So now let's consider the pie chart. We already know what a pie chart is. It's used to represent a given information or data pictorially using the sectors of a circle. So normally the pie chart would have to do with representing it in a circular form. So normally we use sectors of the circle to represent it. And so before that, we would have to find the steps in which, or the steps we follow to have our data represented in a pie chart form or in a circular nature. Now the first one is we have to find for the total of the categories values. So we find the total of the category values. And so for instance, if you are given maybe the following data gives the monthly budget of the family. Food is 60, clothes is $10, house rent is $50, fuel and light $15, miscellaneous $35, savings $30. Then now they say represent the information on the pie chart. Then no, now before you can move to represent on a pie chart, what you are first going to do is you first have to add all the values you were given. So the $60 plus $10 plus 50, these are the values you were given. So after getting the total monthly budget or the total monthly value you were given according to the question, then the next thing you are going to do is you calculate the angle on each category. So I'm going to calculate the angle on each category, and this is how you calculate the angle on each category. You know, a circle is 360 degrees, and so before you can be able to calculate the angle on each this thing. So for instance, let me just illustrate it. Yeah, I'm feeling some backaches. Wow. So for instance, we have something like this. So maybe food, we are giving food to be, this is food. We are giving food to maybe $50. $50. Then maybe rent. Rent was maybe $10. Maybe we had house, or maybe what, clothing. Let me represent it by C. So clothing maybe $20. These were only this thing. They say these are the monthly budgets of the family. The monthly we budgeted food to be $50. This and this and this, and we want to represent the data we've been given in a pie chart. What we first do is we first have to find for the summation of these values. So the summation of these values will amount to $80. Now after finding for $80, we are going to represent it in the form of angles and in a circular way. So we draw our circle using the distance, our compass. So this, we've already done this at GHS level, so we know how it works. So we do it, then you can decide you do your one. So from here you can then you have to calculate the angle for each. So this is how you calculate the angle. You know, a circle is 360, so it's going to be 50. So calculating for the angle of food, it's going to be 50, the value of the food all over the total value, which is 80, by the 360. This is converting it into the angles by the 360 degrees. So the value we get will be the angle for the food. Then we come and do same for rent. 10 all over 80 times 360. Then we get the angle for rent. Then we do same for the clothing. When we finish, then we come and use our protractor and the rest. We come and put it here. So when, for instance, if you divide this into half, we can put our protractor here. It's not even necessary to add this one, but we can just divide it into half. Then we put our protractor here. Then we read from the protractor. Okay, the first one we had was maybe 27 degrees. Then looking at the protractor, when we put the protractor here, we mark, okay, from here to here on the protractor, we mark the 27th degree on the protractor. Then we draw our line to the middle of this. So when we draw a line to the middle of it, then we know that, okay, this part, then we write this part, we write, okay, yes, we write the angle inside. So here is maybe 20 or 27, sorry, 27 degrees. Then maybe it's correspond to food, then we add the food. When we finish, then we come and stand on it, then we draw, we further continue with the angles till we are able to exhaust the values we are given here. And so that is it. Then maybe, for instance, when you're done, then they say maybe what percentage of the monthly budget is house rent. And so percentage, percentage, you multiply by 100. So the percentage will be, maybe if it's house rent, we have 10. So it will be 10 all over 80 times 100. That will give us our percentage. I hope you are all clear on the pie chart. Hello, I hope you are all clear on the pie chart.
Yes, sir.
Okay. So that is it. I'll put some questions on the platform so that you do it for me. Then we can also consider so there are some instances too. You'll be given a pie chart, then they ask you to interpret it. And so looking at the pie chart, maybe they give you here is 20%, here is 90, and all those. And they ask you to interpret. They can ask you what fraction of Mr. Seidu's income is spent on food. So you are going to talk about fraction. Now, when you are talking about fraction, for instance, looking at our angles, maybe you are giving Mr. Seidu's food here. The angle is 27. Here was 27. Then they ask you that in about 10 minutes and we finish. So when they ask you that, what fraction of Mr. Seidu's one was for food? Now, before you can be able to find for the fraction, it will be the angle here all over the total angle, which is 330. That will give you your fraction. And so if the angle here was maybe 27, then it will be 27 over 360. And so 27 over 360 should give you your angle, will give your fraction of what do you call it? The fraction of income spent on food. Then maybe they say, how much does Mr. Seidu spend on rent? That one, looking at the distance, monthly distance, looking at the distance, the chart, you can just detect, okay, it's $50. So you just write of $50. And they can also say, what's the value of the angle that represents savings? So maybe here was savings, and maybe here is 90 degrees. You just write 90 degrees. So that is it. Sometimes maybe they won't give you here. They won't give you here, but based on that, they don't give you here, but maybe they would have given you all the angles here. So to find for this, you just subtract you sum the whole of the angles given, then you subtract it from 360. That should give you the missing angle. So that is it. It is very simple. It is very these are normal mathematics. Then we can also talk about the bar chart. The bar chart. The bar chart normally you it's the same data you be given. So when we are given our data, that's why we can be given the data in either grouped or ungrouped distance. Distribution frequency, distribution table. We have the 5, 10, 16, and those things. And you want to represent it in a graph form. So these are the bar charts looks like. So maybe you draw this thing. This thing. Normally, what do you call it? The verticals represent your frequency. That is where normally your frequency is. Then the horizontals normally represent your max. So given the data, so for instance, how many people looking at your data, you are giving the max and you are giving the frequency. So maybe how many people had 2? How many people had 2? Maybe looking at the frequency, 9 people had 2. So that means you are going to give your scale and so on and so forth. Then you draw a graph. So okay, if I start from 1 here, this thing, these are the max. So I'll represent the max here. I represent the frequency here. So looking at my 1 mark, how many people had 1? Okay, maybe they are 3. So then I map it to maybe the third value here. But normally the bar chart, we leave spaces in between them, and the spaces must be equal. So if you are leaving a whole unit, then it should run through. If you are using a whole, this is based on you and based on your skill for the graph. If you think maybe the distance are plenty that you have to leave just a single distance, that's how you are going to. But normally we leave spaces. So if I leave this space, I should leave equal interval between from this to the next mark. Basically, this is how this thing is. Then from there, we will run to maybe shade or something, or draw lines in it. These are a bar chart. Normally, the histogram, the difference between the histogram and the bar chart is that the histograms are not spaced, but it's the same thing, the same diagrams, but they are not spaced. The histograms are not spaced, and normally they are not spaced. And then normally the histogram, sometimes we consider class intervals. We can normally use class intervals and class midpoints. And so the histogram normally we employ the use of the midpoints. So when you're given a class interval, you find the midpoint of the class interval. And when you find the midpoint of the class interval, you plot the midpoint against the frequency. Are you getting it? You plot the midpoint against the frequency. And so normally with the distance, you plot the midpoint against the frequency. So you plot the midpoint against the frequency. That is how normally the histogram is done. So you can plot your distance. So if you are given class intervals of maybe 1 to 5, 6 to 10, 11 to 15, and you are given their corresponding frequencies, what you do is you find for their class midpoints or their mid values. And what the mid values would have to do is, if you are given 1 to 5, it will be 1 plus 5 divided by 2. So the midpoint you are giving, you are getting 3. So that means you are going to plot here the class mark side. You are going to use a midpoint, and you are going to plot them against the corresponding frequencies. Then you are good to go. But this one, there are no spaces. We don't leave spaces when we are using the histogram. We don't leave spaces. So that is it. I think we have limited time. I wouldn't want to go into this now. Next class, we are going to talk about the mean. We are going to talk about the median, mode. We are going to talk about all these things. Then we are done. Then we go to the part 2, the standard deviation and the mean deviation and the rest. So that's, I'll send you some questions on the platform. This one is data, so I can't be writing all here. So I'll send everything. Listen, those of us who haven't paid, please. I'm broke, so send me money. Send me money. I shouldn't be worrying you. You have to know you have to send me money. That Ruben, talk to me.
Sir, please, yesterday's lesson did not put it on YouTube.
I'll upload it and I'll upload it today. Thank you for reminding me. I'll upload it today. I'll add today's on too. I'll upload it today. Maureen, how are you doing?
Sir, please, I'm fine.
Maureen, you got a guy, rough. Nyansani, how are you doing? Cindy. Daniela, how are you doing? Daniela, how are you doing? Bene, how are you doing?
I'm fine.
I'm fine.
I'm doing well. Just that I'm hungry small. I've eaten Tom Brown though. I'm hungry. Nicole, how are you doing, baby girl? Nicole, how are you?
See, I'm fine.
Mildred, darling. Today I'm so happy. At least I had a lot of people on the platform. That's what we encourage saying. Take your destiny into your own hands, dear, and study hard. Please study hard. Take your destiny into your own hands.